Welcome to week 3, day 1. We're going to be doing section 1.3 distance formula. This is our first day on section 1.3. We talked about how long a segment is and using the segment addition postulate. Now we're going to be looking at segments on a coordinate plane. We're also going to be looking at some of the skills that we had in week 1, which was substitution. So we're going to be substituting into an equation, but that particular equation is going to be called the distance formula. So 1.3 coordinate geometry, midpoint and distance formulas, day 1, but today we're only going to be applying the formula for distance. So you can see that we have segment AB here, and segment AB is on a coordinate plane. So point A has the coordinates x, y, and point B also has the coordinates x, y. So that we don't get them confused, we're going to put a subtext in there. So x sub 1, y sub 1 for point A, x sub 2, y sub 2 for point B. The subtext 1 and 2 have no actual value. So they're not telling you those values are 1 and 2. We're not going to square with them. They're only an identifier. So the distance formula is simply the Pythagorean theorem rearranged. So what we're going to do is we're going to look at segment AB as the hypotenuse to a right triangle. So we're going to add in a right triangle to our picture. So you can see right here, in the Pythagorean theorem, the hypotenuse is generally called C. We're going to call it D for distance. So here's the Pythagorean theorem, A squared plus B squared equals C squared, where A is our horizontal leg and B is our vertical leg. We don't want C squared though. We just want to get C by itself because we just want this distance. So we're going to square root both sides. So this is the basic format of the distance formula. It's the Pythagorean theorem rearranged. So when I go to show you what it looks like, it is going to look a little different, but that's okay. We'll get it clarified. Okay. So C is really the distance. We know from a previous lesson the distance between point A and point B is the length of segment AB. So the length of segment AB is equal to the square root of A squared plus B squared. That doesn't look like A, that doesn't look like B. So how did I get A? How did I figure out how long this side was or how long this side was? Well, it's a little easier if I describe it for the vertical because I think about it as a thermometer. So if it was 55 degrees in the morning, and 105 degrees in the afternoon, then the temperature went up by 50. And the easiest way to think about that is 105 minus 55. So even though this is going to be A squared, the formula tells you how to get the A. So you're going to subtract. So you're going to subtract the two values to find out how far apart they are, which gives you the A and the B. So let's say this again one more time. The length of a segment, so the length of segment AB is actually the distance from the endpoint to the endpoint. So the length of segment AB is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Again, it's simply just A squared plus B squared, but the formula, the distance formula shows you how you got your A and your B. So the first question here says, find the length of segment RS. And it gives you the point R is at -7, -5, and S is at -3, +7. Now you can graph this and make a right triangle, but you don't have to. We know the formula. We know the formula is the length of RS equals the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. because remember, the length of a segment is calculating the distance. Okay, so the question becomes, how do you do this? These subtexts are really just telling you to keep the order. Whatever order you pick, you should stick with it. But I like to just do what it tells me to do. Go to the second x. The second x is -3. Go to the first x. The first x is -7. And substitute them. So -3 minus -7. Then it says go back to the second y and subtract the first y. So 7 minus -5. Now we know algebraically that subtracting a negative is really a redundant thing to say. So yes, you could write this, but you'll see it's in red. So really what I'm doing is I'm just thinking this. What I'm going to write is the length of RS equals -3 plus 7 squared plus 7 plus 5 quantity squared. Okay, so now we need to do order of operations. So inside the parentheses, we have -3 plus 7, and over here we have 7 plus 5. We're going to write everything else. We're going to write square root 4 squared plus 12 squared, and now you can see there's the A and there's the B. Now you'll notice I did not write the length of RS right here, and that's because this left side isn't changing, so I really only need to do it at the top and the bottom. Continue with order of operations, so I continue to write the square root sign. 16 plus 144, so the square root is 16 plus 144. Continue, equals the square root of 160. Now 160 is not a perfect square. It does have a perfect square in it. It is 16. It's 16 times 10. So I'm either going to simplify it. The square root of 16 is 4. The square root of 10 you can't do anything about. Or I'm going to stick it in a calculator and I'm going to make a decimal out of it. So it's approximately 12.65. Make sure that you always use 2 decimal places. Okay, so we're going to try that one more time. Find PQ. What? Wait a minute. That looks different than that. Yes, because this is writing it in words, length of segment. This, question number 2, is writing it in shorthand notation. It's still saying find the length of segment PQ. It's still saying find the distance from point P to point Q. So P is at the ordered pair 4, 3, and Q is at the ordered pair -1, 6. Remember, you can graph it, but you don't have to. What you do have to do is you have to write the formula without any given numbers. The more you write the formula, the more you're going to remember it. So the length of PQ equals the square root of x sub 2 minus x sub 1 squared, so there's your A squared, plus y sub 2 minus y sub 1 squared. So here's your B squared. So now we're going to substitute. And again, as long as you pick an order and stick with it, you're fine. I just like to do what they tell me. So go to the second x, -1, and subtract the first one. So -1 minus 4 squared, plus go back to the second y and subtract the first y. So 6 minus 3, quantity squared. Order of operations says stay within the parentheses. So equals the square root of -5 squared plus 3 squared. Continue with the order of operations. So PQ equals the square root of 25 plus 9, which equals the square root of 34. Now 34 is not a perfect square, and it does not have a perfect square in it because it's 17 times 2. So we're just going to turn it into a decimal. It's approximately 5.83. So make sure you write the formula. Make sure you substitute the formula. Substitute the formula. And then do order of operations. If you got something like the square root of 25, then you would want to go ahead and make that a 5. Make sure that you take your time through these notes. If you didn't get anything, please go back and watch the video again. Make sure that you're taking notes. If you have any questions, email your teacher. If you need extra assistance, request a Zoom. And good luck.